For today's video, I will be doing problem number 1 from 6.2, which asks us to use the shell method to find volume by revolving the shaded region about the y-axis. And in that homework problem, they give us the equation y equals 2 plus x squared over 3. And they give us this graph, which goes from 0 to 2 on the x-axis, 0 to 5 on the y, and this curve here. And the shell method volume for a vertical line, as we see there is a vertical line here, x equals 1 right there, is the integral from b to a 2 pi shell radius, shell height dx. And when we want to find our b to a down here, to integrate, I looked at the graph and noticed that it went from 0 over here all the way to 2 and stopped. So I knew that my a was going to equal 0 and that my b was going to equal 2, since that's that x interval right here. For the radius, I chose it to be x, since we're looking at this interval part and we're looking at the x axis here. And the shell height is f of x, and the f of x is equal to y, which is equal to the equation they give us right here, which is 2 plus x squared all over 3. And what we're going to do when I flip the page over is I'm going to rewrite this equation out, and we're just going to plug in these values. We're going to plug in the shell radius, we're going to put x here, the shell height here. We might simplify it down a little bit, and then I'm going to integrate it, and that will give us our answer for volume for revolving the shaded area about the y-axis. So our volume again is equal b to a 2 pi. I'm going to write SR for shell radius and SH right now for shell height dx. So b is equal, we said that b was 2 and the a was 0 of 2 pi. We know that the shell radius, as we stated before, was x, and the shell height was f of x, so 2 plus x squared all over 3 dx. And then the next step that we are going to do is pull out this constant right here. So I'm going to rewrite it as 2 pi 2 to 0 x 2 plus x squared over 3 dx. And again, then I'm going to simplify this and multiply the x through. So I get 2x plus x to the third all over 3 dx. And this right here is going to give us the function that we want to integrate this right here from 2 to 0. So when we rewrite that, we have 2 pi on the outside, and I'll put parentheses. The integral of 2x is 2x squared raised by power divided by the power, so those 2's cancel, plus I'm going to pull the 1/3 right here out to make it simpler. 1/3 x raised to the power, so 3 to 4 all over that power 4. And when I rewrite this, I get 2 pi times x squared plus x to the 4th all over 12. Then I'm going to multiply my 2 pi through. I'm going to get 2 pi x squared plus, and when I do 2 pi, I'll write this all out just so that you can see it, x to the 4th all over 12. I can cancel out the 2 here. That just becomes 1. I can cancel, take 2 out of here and get over 6. So then we're left with 2 pi x squared plus pi x to the 4th all over 6 from the values of 2 to 0. And now we can use our fundamental theorem of calculus, plugging this into this function, minusing it from plugging this value into the function to get our final volume. So I have 2 pi 2 to the 4th. Oops, sorry, 2 pi 2 squared plus pi 2 to the 4th over 6. And I know that when I plug the 0 in, if I was going to minus the 0, this times 0 is 0, and this all times 0 is 0. So instead of writing that all out, I'm just going to leave this is what we're left with, and now we need to simplify this down. So that gives us 2 pi 4 plus pi 2 to the 4th is 16 over 6, which I'm going to give this and write it down here. We have 8 pi plus, and then 16, I take out 2 from each, I'm going to get 8 pi over 3. And now I just need to make this so I can add them to common denominator. So I'm going to put a 3 on the bottom, times it by 3 on the top, and make it 24 pi, over 3, plus 8 pi over 3. And finally, our final answer, 24 plus 8, is 32. We get 32 pi all over 3 as our final answer for the volume for revolving that shaded region about the x-axis. And that's how you do 6.2, problem number 1.